Hello everyone, I hope you have a great weekend. We first start with Unity today and the backend is already running currently and we will connect with Unity to the backend. Let me show you what we built today. When we start, we see a login screen with login and register, and we can create an account, for example like this. And when we press login, it will say wrong password or email. That's because the account isn't registered. When we press register, we also get logged in. And then we can come to our character screen where we can say something like my character as a name. We can select multiple eyes. You can see they change here. Let's pick those and maybe pick this color, and when we create, we can see at the bottom that we got a token back with the character. So when I change something now and I press save again, it will be corrected by the backend. Normally we will go to the map now and start playing the game, but that's for the next videos to do. So let's check at the source code first, and then let's check in Unity what I have done to make this possible. First of all, in the source code there's something where I want to start, which is called Unity Dispatcher. What it does is, when you do something on a UI, for example change the display text or something like that, then for most UI systems you have to do that in the main UI thread. For Unity that's also true. There's one trick to do that, and that is to have a queue where you can queue things that you want to execute on the main thread, and the main thread will take this queue and execute it for you. So we have this function run on main thread. This class is static on the way. While we start developing things, we will remove this static class and make it singleton, but for now it's static and we will later make it singleton. It has a queue, like I said, and when we call run on main thread, then an action will be added to the queue, and we have one coroutine in Unity who will execute those actions, which makes it possible that those actions, even when they come from other threads, will be executed on the main thread. Also, what we need to have is our pub subsystem aligned with the Unity threading. So we want, when we publish something and one Unity UI component subscribes to it and changes values depending on what happens, then we want this to run on the main thread also. So what we do is, when we publish something, we call our introduced run on main thread, and this will make sure that the execution of our registered subscribers will run on the Unity main thread. And apart from that, it's the same as the backend code. We can subscribe to different type or different events that can happen, and we can publish the event, and every subscriber that is subscribed to the event will receive the event. Then we have a dependency injection. I developed a very small DI container, and we will leverage that DI container within Unity. What we also have is we have language, and currently we have just English as language. The easiest way to implement language in your application is to have a iLanguage interface, which defines the common text that is available, and then later when you introduce multi-language, we just need to switch in the DI container what is iLanguage, and everyone who leverage iLanguage will get the right text for everything. So in our DI container, we have iLanguage English, and we could change that to German or whatever language, and everyone that uses iLanguage to get some text will then get the updated version for the text. So the text could be in a different language. Also, we have our client wrappers, which are small wrappers of the backend clients. Since we have the backend clients already implemented, these are some wrappers around it to make things easier for us. For example, here we want to create different threads so that the Unity UI isn't blocked. There's a problem actually with those one, even though they are async. It sometimes happens that they run synchronously, and to fix this issue completely, I create another task to call that. And then we have our UI system, and our UI system works like that. It's kind of a model view controller system. We have controller which control each screen. For example, we have a loading screen, and our loading screen is able to show an action, and it has a progress bar which shows how much percent is currently processed. And when we check out in Unity and we check out the loading screen, each screen in our Unity is a panel, and within this panel we can do or create the screen that we want to. For example, we have a title which is just a TextMesh Pro label, and there's just loading in it, and later we will have the controller get the iLanguage interface and replace the screen title, for example, with the according language text. Then we have a body, and within the body we have a text which currently just say loading ... and we have a text for which action is actually happening, and at the bottom we have a slider with our progress bar. And when we start the application, it might be too fast, but you see very shortly the loading screen. We can introduce a little bug where we connect to the wrong port, maybe a port which doesn't exist, and then we see the loading screen in action, because if it can't connect, then we will stuck on loading. Here it tries to connect to the login server and connection failed, and we actually don't have code to handle that properly, so you have to restart the application. Let's check how this works now with the system. We go into init client, which basically initializes the login, which is just on scene loaded, our first thing we do. And the client initialization calls a function which here is called upgrade progress. And upgrade progress just published a control loading screen. And what we have here is the control loading screen, which gives, is it visible, which percentage, and which actions to show. And throughout the code, you see loading with some percentage and what are we actually trying to do. And then 40% we are trying to connect to the backend. That's what we saw, and if that fails, then we have 100% connection failed, and as you remembered what we just saw, we were ending here. And the happy part is doing the encryption handshake. Because this is login, we actually send username password over the wire. We want to encrypt that, and we have an encryption handshake which is pretty close to TLS, and we do that handshake, and if that handshake is successfully, then we are connected successfully to our login service to the backend. And then we send a publish event that we want to display the control character screen. Oh, sorry, I went for the wrong one. For login, we have the handshake, and after we connected successfully to the login, then we want to show control login screen. For the character, it's pretty much the same. That's why I missed that. Sorry. So also what we do update progress 100%. We have no action anymore, and we do visibility false. So if I uncomment this line, then the login screen won't show, but the control loading screen will visible false and deactivate the loading screen, which just happens. It's quite fast. And yeah, this basically control login screen works pretty much the same as the loading screen. The default value for visible is true. When I just call the default constructor visible is true and I publish that, and then the actual screen controller will subscribe to those events for both screens and will handle the screen accordingly. So when we have here control loading screen, for example, that's the event. When we have the loading screen controller, we see it will subscribe to the control loading screen, and when, for example, visible is false, it will set the loading screen active to false or true. So we have those controllers. Those are always controlled with publish subscribe, and everything can publish and subscribe and control the screens that way, which decouples the screens completely from application code, and that's exactly what we want. We also have events over our pub subsystem to our clients. For example, we want to try to log in with an email and password, then we have an event called try login under pub sub events. And when we check this out, we subscribe, our client wrapper, when it's initialized, subscribes to that event, and it actually tries to log in, which just calls our client, which the server team wrote for us. And when the client successfully logged in, we get the client messages as pub sub messages back to us. And when we check out the server code real fast, and we check out login client, it will, sorry, when we check out the workflow, when we check out the login workflow, when we receive a message, it will publish the message via our DI container iPubSub. And since the client overrides in the iPubSub with our Unity PubSub system, even though the server client will send a message via it, we will be able to subscribe to it. And when we go real fast to subscribe with an action, because that's what's happening, then we have here login register response. And if the login register response comes back in, we have our on new login token, which will just save the token and initialize the next client. That's how the whole system works. Everything is decoupled with our pub subsystem. For example, for the message login register response, we have two subscribers, one which initialized character client, which connects basically to the next service to the backend. And the other one just displays on login screen the result code. And when I give wrong information, for example, a login which doesn't exist, then this invalid email is basically this subscriber here, which basically says set the text of the result code to the response we get from the backend. Normally we want to display something more beautiful than the enum, but I want to make progress, so I tend to not bother too much about those things. And the other one, which is pretty much handling the success path, is on new login token. When we get a token and when we log in successful, then we initialize the next character client. And what it actually does, it disables the login screen. So we set login screen visibility false. Then we have a loading screen again where we do connect to the character client, which for example, we can do the same like we did with the login screen. We give it a wrong port, then we can actually see what's happening, because else it's too fast. And when we log in correctly, then you can see it's connect to login server, and actually it's connecting to the character server. So we found a bug here, so let's fix that real fast. It's not connect to login, it's connect to character. And we can go to implementation. We just have one, so it will jump in there. Implement the interface, and then we can do equal connect to character. That's actually what we are doing. So let's try that again. Oh, I clicked too often. And it still says connect to login server, which is actually wrong. Maybe I didn't save this one file, which yes, connect to character server, so I forgot to save the file, and when you go back to Unity it's still compiled because I changed something, but I didn't save the file. So always make sure when you're in Visual Studio to maybe press this button, save all, which save all files, to not have this issue. So this was a fast run of the code. So if you I suggest you check out the code via Git. It's linked in the description, and maybe at the part where I went through very fast, you pause the video, you go to the same code section with Visual Studio or with VS Code, whatever IDE you're using, and then you try to read the code yourself and with the video to fully understand it. If you didn't understand any part of the code or whatever and it was too fast, feel free to write a comment on YouTube or to join our Discord community server and ask anything about the code and everything there. I will try to answer everything I can. How does this work in Unity? What we have one game object, which is our framework behavior, which has to stay alive, which is basically this framework behavior is our entry point for us to do things, and it's also the one thing that's executing our Unity dispatcher so that the queue gets executed. It's in the update of the framework behavior. So we have an empty game object, which is just our whole system, and which updates the queue and everything. Then we have a main camera. I didn't change too much here because we are just in 2D space for now. So then we have a post-processing volume. We will later use that to introduce bloom and everything. This is universal render pipeline, and this is a default scene. I just deleted everything apart from post-processing volume. Then we have our start canvas, which is the canvas where our UI system will live in. Maybe the name is not great. We will rename that to UI canvas maybe. Let me do that real fast. And then we have the event system. We use the new input system, so there has to be inside the new input system. Apart from that, we don't need to change anything. It's Unity default. And we have a background, which is just an image, which is the background image you see here. And then we have our different screens implemented with the Unity UI system. And when our UI canvas holds all three controllers of our different screen, and each controller is configured, for example, for loading screen, it's having the game object of the panel. So when we deactivate or activate the loading screen, this whole panel is activated or deactivated. And then we have the according text or progress bar or whatever the screen controls in it. And when we check, for example, the login screen, then we have those fields set by our UI canvas. And when we want to read what email is inputted by the client, then we have this email read, which is basically when you are in Unity, you can drag and drop your items in here, and then you save, and the link is created, and Unity will fill out the properties when it runs. And for these two functions, login and register, Visual Studio doesn't understand Unity in depth, so here it says reference 0, but this code is actually referenced. When we go to the login screen, then we have our login button, for example, and then we have the login controller on click, and what we do is we call the login function of it. So we have the canvas, which has all the controllers. You can see it here, and I selected the login screen controller with the login function. And so this function is called when we press the button. This function just publishes try login. Our login client will listen to try login and will call our server client to log in or register. So this is login, to log in, and we get from the server back a login register response message, and then over our pub subsystem we leverage the response. When working with the Unity UI system, I really like to set scale with screen size in the canvas scaler. If I don't do that, then, for example, if I have constant pixel and my screen size actually changes, it stays. The screen is always as big or as small as I configured it. But when I set it to scale with screen size, and let's say you have a smaller screen, then as you can see, the canvas tries to keep the UI as big as it was. There's also another aspect of the Unity UI system. When I have a different screen ratio, I can configure it here to 16:9, which is basically default for modern screens. Then everything is looking perfect with my UI, how I built it. But when we have free aspect ratio, then depending on what aspect ratio you have, the screen might look awkward or not good. But I configured everything as best as I can to have it good looking even in different aspect ratios. One thing I recommend, like I said, is scale with screen size. And the other thing is, when you're building a screen, you have to properly set those anchors. For example, when I have an anchor when I set this to top anchored, then you can see the anchors here. These little dots are the anchors. They are now in the middle, and when the outer border moves, then the the size of the container stays the same, and we normally don't want that. So when I, for example, anchor it like with that button here, then you can see the anchor moves right and left, and when the outer border now changes, then the title size changes with the outside border, which makes resizing the screen and everything easier if you do that correctly. I could also pick this one, which basically creates the anchors at the whole outside container. So it also changes its height when I move that. But since my text size won't change to be good readable, I don't want the title to change its height. I just want to be possible to have it moved on left and right. And the same goes when you pick one of the bottom ones, then the anchors are at the top, at the bottom, but middle. Then it basically works for the height and not for the width. I often get asked how to configure those things correctly. The other ones is basically where the position is calculated on. Currently it's on top, so we see position Y is 0 because it's at the very top, and when I put it at the middle, then the position is calculated from the middle line here, and we have to go 235 up, and if we go even lower, then it's calculated from the bottom. That's how this whole anchor system works. And then what you do is, when you implement a new screen, you create a UI panel, and then in our case you name it, let's say chat screen, and then you create basically inside the things you want to have. For example, let's say we want to have something like we have for the login screen. We have to check how big this is, and then we can say it should be a little bit lower, maybe here. And maybe we want to have it centered, and then we can change the alpha. We can also do, it has the background. Let me just copy that. Then when we change this value here, how the image pixel per unit changes how far the image basically is zoomed. So when I lower this value, then the image is more scaled to the screen size, 0.4 gives me the outer border of the image just fine for my configuration. So I can see a little bit of the border here, but not too much. And then we have another panel for our title, for example. And then again, we want to just have it like that. And we pick our color for it. And we size it accordingly. And it's also 0.4 for it. And then we create another one, which is maybe a text mesh pro text. And we copy our values because there's no need to reinvent the wheel every time. And we paste it as values and we give it the proper size. And then this would be the chat. I think you get the idea how to build things like that, and then we need to write a controller and get the controller here ready, which works just the same way as any other controller. Also, what the system currently supports, which I didn't leverage because I didn't need it that for now, is we could have multiple screens at the same time. There's a very easy way to show that. When, for example, the login is successful, then let's just not hide the loading screen. So now we see the loading screen and the login screen behind that. And in the future we will implement that when you click the title screen that you could move around the different screens, which is actually quite easy to do. When we have that, we could, for example, in our game at the bottom left have our chat screen and you can move that around, and when you open your inventory you see it in the middle screen. And we could even save to player preference or even in the back end where the player has positioned the screens, so that when the player modifies its UI and he relog in to the game later, the screens are positioned like he has done before, which is always a pretty neat feature if you ask me. That's everything we have done in Unity so far. And the next thing will be in Unity to implement walking around on a map and seeing other players walking around. If you like what you have seen, it would help me a ton if you like and subscribe to this channel. I wish you all a very great weekend. Bye.